vertical asymptotes, horizontal asymptotes, and oblique asymptotes. The following three examples demonstrate how to find the three different asymptotes. The graph of a rational function will contain one or two asymptotes. Example 1. Find any vertical asymptotes for the following rational function. Now this is a rational function, so because it has a fraction, x minus 3 divided by x squared minus 5x plus 6, where the numerator has a variable in it and the denominator has a variable in it. Now this will contain one or more asymptotes, but all we need to do in this particular problem is find the vertical asymptotes. Well, vertical asymptotes are created when the denominator is 0. So this kind of changes this problem to find the zeros of the denominator. Let x squared minus 5x plus 6 equals 0 and solve. Therefore x squared minus 5x plus 6 equals 0. And we can factor it, so we have quantity x minus 3 times x minus 2 equals 0. And this implies that x equals 3 and x equals 2 are zeros, so they make the denominator 0, and so they create two vertical asymptotes. One at x equals 3 and the other one at x equals 2. Example 2. Find any horizontal asymptotes for the rational function in example 1 above. To find any horizontal asymptotes, we follow the rules below. If f of x is equal to a sub m x to the mth plus plus a sub 0 divided by b sub n x to the nth plus plus b to the 0. Now don't be intimidated by this. This is just a polynomial divided by another polynomial. It's just that we have the degree of the top one is m. In other words, the largest power of the variable is m. And the degree of the denominator is n, which is the largest power of x in the denominator. It's this m and n that we're interested in. So we'll look at those three rules. Rule number 1 is if m is less than n, we do something. 2, if m is equal to n, then we do something. And 3, if m is greater than n, then that will cause us to do something else. So we look at this for our particular problem. If you notice in 1, if m is less than n, then that implies that y equals 0 is a horizontal asymptote. So we'd be done. Y equals 0. If m equals n, that implies that y is equal to the number a sub m over b sub n, and that is the horizontal asymptote. And 3, if m is greater than n, implies there is no horizontal asymptote. Therefore, in the problem in example 1, we look at the degree, the m and the n, and the m on the top is 1 and the n on the bottom is 2. So therefore, we have that m is less than n. So that implies that y equals 0 is a horizontal asymptote. Example 3. Find any oblique asymptotes for f of x equals x squared plus 2x minus 5 divided by x minus 2. Now to find the oblique asymptotes, you divide the denominator into the numerator, and then you get the oblique asymptote from your answer. So when we divided the function x squared plus 2x minus 5 by x minus 2, we get x plus 4 plus a remainder of 3, so we write that as 3 divided by x minus 2. Now what we do is we just take that x plus 4 that's out in front, we ignore the remainder, just take the x plus 4, and that'll give us the oblique asymptote, and in this case it is y equals x plus 4. Y equals x plus 4. In all of these cases, it would be good to graph them and take a look at it. Kind of see how things are going, what the vertical asymptotes, the horizontal asymptotes, and the oblique asymptotes are really telling us.